So we are continuing in chapter 5. We have a couple more sections that we are going to look at. The first one, today we'll talk about powers and roots. This isn't really new stuff. We did it at the beginning of the year, but we're just kind of refreshing and making sure we remember all of those things from early on. So, when I talk about a power, what is that? The exponent. Yep. So power is an exponent. What if that power is a fraction? It's a root. Okay. So if I said, like, let's say x to the 2/3 power, what does that mean?
It's the third root of x squared. Yeah.
So if you have a fraction, the denominator goes outside the radical. The 2, it can be under the radical or outside. It doesn't matter. It will be equivalent either way. All right, let's talk about these root functions specifically. So if you have that kind of thing, what's the domain? So first let's talk about even roots. So if I have like a square root, 4th root, 6th root, and so on. Is there any stipulation on what kind of numbers need to be under there? What if I say the square root of -4? What does that equal? 2i. So if we don't want i's, if I only wanted real numbers, what would have to be under my square root to avoid? It'd have to be positives if I just want to avoid i's, right? Could we do the square root of 0?
Yeah. Yep.
It's saying what to the second power equals 0?
0.
0. 0 squared is still 0. So for those even roots, the domain is 0 to infinity. It has to be a positive underneath. Alright, now odd roots are a little bit different. So if I have a cube root, 5th root, 7th root, and so on. Can you do the cube root of -8? What is it? It's -2. The cube root of -8 says what number to the 3rd power equals -8? And it's just a -2. When we graph the cube root function, remember, yeah, the square root function just looked like this because it had to be positive, but the cube root function was like the sideways chair. It went forever in both directions. We could have positives or negatives. So if it's an odd root, the domain is everything. We don't care if it's positive or negative under there. It'll work. Ooh, no.
What is happening?
Well,
Tablet started slow.
it's a brand new one. We'll see how well it works. All right. Let's practice simplifying some of these radicals.
Oh, time to get
No, sit down. We don't need calculators. We can do this.
That's 3.
All right, everybody better be with me here. So the cube root is 27. It's like saying what number to the 3rd power equals 27, which is 3. B. If there's a negative on the outside, does that change anything?
No.
It just means my answer will be negative. The 4th root of 10,000. Do you guys know how to do 4th roots on your calculator? Just
Yep.
you go into the math the cube root of negative 216.
Nah. 16.
Oh my goodness. Well, why don't you guys grab a calculator and then check it for me then. We have a lot of debate here.
Grant?
No, why didn't you put a calculator?
It is
Oh, you got me, Grant.
negative 6 to the third is negative 216.
But,
Alright,
Carson was right.
fourth root of negative 81. Okay, since this is an even exponent and we have a negative underneath, that tells me we'll have an I with it. Because you'll never do a negative to an even power and get a negative answer. And then the fourth root of 81 is 3. Notice I'm not putting plus and minus on these. That's only if you add the radical in the problem. Otherwise, I'm just asking you to solve what we have here. When you have fractions, you can really just do the top and the bottom. What's the cube root of 125? What's the cube root of 512?
8.
Alright. F. A negative fifth root of negative 243. So we have a negative on the outside. The fifth root of negative 243, negative 3, and 2 negatives would make a positive 3.
Okay.
So can we handle these types of problems?
Yeah.
I think we need that for homework by itself.
Well, there will be some of these. That helps.
All of it.
Let's practice if I write it first with the fraction exponent. It's the same thing. So if I said 16 to the 3/4 power, what would that look like with a radical?
Fourth root of 16 cubed.
What is the fourth root of 16? 2. And 2 to the third?
Oh, I just did 16 cubed.
You could do 16 cubed and then do the fourth root of that. You'll get the same answer.
How do we?
Alright.
It's 8.
B. What is the cube root of negative 64? And negative 4 to the fourth. On this one, you have to be careful that negative is inside the parenthesis, which is what makes it turn into a positive 256. C, we have to kind of refresh our exponent rules. What do you do if you have a power to a power? Multiply. So 3/4 times 2. It would be 6/4 or 3/2. So this is the square root of 25 cubed. What's the square root of 25? And 5 to the third. D. So negative 8 to the 5, that means the cube root of negative 8 to the 5th power. So the cube root of negative 8 and negative 2 to the 5th. Alright. Are there any issues with these types of problems?
I'm running out of tape.
Turn to the next page.
Yeah. I have like.
Use the back of that sheet of paper. So now that we know what we're doing, let's do it with variables.
What?
All right,
How many pairs can you do?
let's start simplifying this stuff. So if I have the fifth root of x, how would you write that with a fraction? That's x to the 1/5 power. This is the square root of x cubed, so that would be x to the 3 halves. When you are multiplying, what do you do with the exponents? Add them. So what's 1/5 plus 3 halves? So this gives us x to the 17 tenths.
Yeah, we're too good.
I'm gonna do, well, can I do C and then you guys try B and D on your own? Would that be okay?
But C is easier.
Okay, this whole thing is under a cube root. So what power is a cube root? 1/3. Then underneath this we have an x squared times, what's the 7th root of x? How would I write that? So inside my parentheses, if you're multiplying, what do you do with those exponents? So 2 plus 1/7.
2 cents.
You multiplied them. You need to add them.
Yes.
And then that's to the 1/3. If you have a power to a power, what do you do with those exponents? Multiply. So 15/7 times 1/3, which is 5 seconds. All right, you guys try B and D. So the first one, the cube root of x to the 4th, that's x to the 4/3. The 4th root of x to the 5th, that's x to the 5/4. Since the x is written each time, when you multiply, you add those exponents, so you get 21/12? 31/12, yes, sorry.
Miss Thorpe can go anywhere right now.
And I missed my board so much.
She's portable.
Alright, so this one, if it's a 6th root, we would write that whole thing as a 1/6. Underneath we have x times, this would be x to the 2/3. So within here, since the x is written each time, you add those exponents. If there's nothing there, it's assumed to be a 1. So 1 plus 2/3, so that would be x to the 5/3.
Oh.
To the 1/6. So that's x to the 5/18.
Yeah.
Alright, is that okay? Last thing I want to do today is just a little bit with finding domains. So remember, if it's an even root, it has to be greater than or equal to 0. If it's an odd root, it can be anything. Now we do have to think about transformations if we're talking about these graphs. So I'm not going to have you graph them, but I want to use the knowledge we have about transformations to find these domains. So there would be different options for how to solve that. One option, you could rewrite this so you can easily find the transformations and you could go from there. The other option would be to say, well, this is an even root, that's understood to be a 2, so basically whatever is underneath the radical has to be greater than or equal to 0. And you could get the domain either way. So if I did that, x has to be greater than or equal to -3. So how do we write that?
Bracket -3.
So if it's an even root and I ask you for the domain, you really just have to take whatever's underneath the radical greater than or equal to 0 and solve. What about if it's an odd root?
Isn't it negative if you're in puzzle?
You don't even have to solve anything. If it's an odd,
Okay, you're so.
it's an automatic negative infinity to infinity. I'm going to do,
I got a question.
uh-huh.
You said I would like to.
How do you know if it's greater than less than?
It's a graph.
It's always greater than or equal to 0. If I asked you to use a graph to get the domain of the square root of 36 minus x squared. So what would we do?
Can you just find the square root of that, or is that not?
Well, because of the inequality, it's going to be a little bit different.
I see.
That would kind of get us close. Let's look at the graph to confirm that.
Oh, yeah.
That's,
It's a little upside down.
So the square root of 36 minus x squared. What's this give us?
Something, because it's plus or minus 6.
Yeah. If you just set the inside equal to 0, you get positive and negative 6. What we see is our graph starts at negative 6 and ends at positive 6. So my domain is everything between negative 6 and positive 6. Alright, so if it's something more complicated, if it's not linear, if it's a quadratic or something underneath, you could use the graph to help get your domain. Huh?
How do we know it's included?
Because you can do the square root of 0.
Okay.
I knew the range for that one.
Oh, what is the range?
It was like 1 to 5 or 6.
It would, yeah, it would go 0 to 6. If we zoom in, you'll see more. I know, it doesn't look like it. Okay,
Oh, hold on. You said you were done.
You did say it would be done.
You lying. No,
You
no,
were
no.
lying.
No, you
Last
lying.
little
Lying.
thing.
You lying.
Cavern.
Alright. I want to know, based on transformations, can you tell me how I would use transformations to graph this?
Yeah.
Okay.
Or
Horizontal.
The horizontal stretching and shrinking was kind of challenging, right?
I can't.
One option we could do. What could you factor out of both of these?
4.
Okay. And if you take that out, you have an x plus 3, correct? Can we do the square root of 4?
Yes.
It'd be stretched by 2. Or stretched by 2.
Mm-hmm.
Stretched by 2 left 3.
Look at that.
Vertical stretch by 2. And left 3.
Now you gotta be done.
What's the homework?
So, last one of these, you guys do one on your own.
You lying.
Oh my goodness, if you guys complain one more time, I will add to your homework.
We love us.
We're just
Lying.
kidding.
So, if you take out the negative 8, that leaves it with x minus 1. Cube root of negative 8 is negative 2. Okay. What does a negative do?
Flip over the X. Flip it in reverse. You gotta pick.
What's the 2 do?
Vertical stretch.
I won.
And minus 1 takes it. Okay. There is a Math Excel assignment open.